Okay, this is a tricky question for sure. This is difficult for HL, never mind SL. So it's the last short question on the SL paper, which is always a difficult question. Part A is okay. That says show that sine 2x plus cos 2x minus 1 equals this. So if it's a show that question, guys, I'm just going to do left-hand side. So we'll start with the left-hand side, which is this, and kind of turn this, well, turn this into this. So these are both the double angles. Well, they're double angles, so we're going to use the double angle identity. So sine 2x is 2 sine x cos x, 2 sine x cos x, and cos 2x, I'm going to use the 1 minus 2 sine squared x. I've chosen that one because we have a sine x here, and this sine x times sine x is going to give me my 2 sine squared x, and then minus 1. And this equals 2 sine x cos x minus, so the 1's cancel, we've 1 minus 1, so it's just minus 2 sine squared x. Now I can take out the 2 sine x, and I'm left with cos x minus sine x q e d shown. Okay, that is part A, so that was fine. Part B. This is where it gets tricky. So it says, hence solve this equation, right? So when he says hence, guys, basically always, I think it says hence or otherwise, but I just put hence. Always go with what you've done from the part A. So part A, we showed that this equals this. So let's turn that into this. So instead of this equals 0, I'm going to say this equals 0. 2 sine x cos x minus sine x plus cos x minus sine x equals 0. So I've turned that bit, I've turned this bit into this, because that's what I did in part A. So the next part is, well, as I say, tricky. And what we need to do is factorize out this cos x minus sine x. So you kind of have to, and you may ask me why on earth, or how on earth did I know how to do this? So I'm going to look at that, and this is kind of almost two separate terms. Like this is a term and this is a term. And what are the common factors? What's in this and also in this? Well, cos x minus sine x. So I'm going to take out the cos x minus sine x. Take it out, as in factorize out. And what do I have here? Well, I have 2 sine x. This bit's left. And then plus 1. Because I've taken this whole thing out, or I've divided by cos x minus sine x, I'm left with plus 1 equals 0. Now, how did I know how to do that? Well, the kind of main reason, well, there's two ways. One, if you try, I might have tried other ways to do it, like multiplying this out, trying to make a tan using some kind of identity, and I'd quickly find out that it just there's not really anywhere to go. But the reason I knew to do this is because I would have asked the question, well, why on earth are we doing this in the first place? Like, why is he making me turn this into this? Why not turn it in, why not just say 2 sine x cos x minus, why not leave it like this? Why is he factorized out this? So, you could argue, well, that's slightly more simplified, but the reason he's done this is kind of, he's deliberately put it in that form to help you see this thing that I've just done here. But yeah, look, it's hard. And in an exam situation, for sure, not everyone is going to think of that. Okay, so now I have both of these. I can say cos x minus sine x equals 0, or 2 sine x plus 1 equals 0. Solve this. I'll say sine x equals cos x, sine x over cos x equals 1. divided by cos x, and then tan x equals 1 because sine over cos is tan. So that's my first kind of equation. And now I have 2 sine x equals -1, sine x equals -1 over 2. Okay, and this is why I say this question is really hard, because I mean this bit, like this bit alone is tricky. Then this bit, to write it like this is hard, and then even if you get this far, you still have to solve these trig equations, which we all know are notoriously difficult, especially because x is between 0 and 2 pi, so I'm going to have lots of different solutions. So x is between 0 and 2 pi. Okay, so I'm going to use my cast diagram. Cast, C-A-S-T. Okay, I'm going to first do inverse tan of 1. Gives me pi over 4. You have to know this, guys. Inverse tan of 1 is pi over 4. This is positive, so it's going to be in the all quadrant, and it's going to be in the tan quadrant. So this is pi over 4. So x is equal to pi over 4, or this one, which is 5 pi over 4, because it's pi plus pi over 4. Sometimes I like to do 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So this is 5 pi over 4. And I stop there because x is between 0 and 2 pi. And then this guy, inverse sine of a half. I just do the positive version, guys, because I can deal with this negative after. So inverse sine of a half is pi over 6. Yes, you do need to know that. And then I'll do another cast diagram here. C-A-S-T. So, sorry, I should have said, guys, this guy is all and tan. Now this guy's negative, so he has to be in the tan quadrant and the C quadrant. And it's pi over 6, so he's going to be here. And he's going to be here. And this guy is pi plus pi over 6, which is 7 pi over 6. And this guy is 2 pi minus pi over 6, which is 11 pi over 6. So guys, these I know are always not easy to do. Just make sure you can do them all. So again, if you want to think of it as 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, that's that solution, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. And these are my 4 solutions then. So I'll just write it finally. Therefore, x equals pi over 4, 5 pi over 4, 7 pi over 6, and 11 pi over 6.